All right, hey everybody, welcome back again. Hope you had a good Christmas break in J-term. We're going to be back at it here in Algebra 2. Mr. Anderson here again, and today we're going to talk about dividing polynomials. We're in section 5.2, part A. Okay, we're not going to do the whole thing today. Today we're just going to talk about part of this, which will be the long division. Okay, so let's look at our objectives to start out. And what we want to do today is divide polynomials using long division, as I had just mentioned. Alright, so let's start with this one. First thing that we're going to do, we're going to divide a polynomial by a monomial. And you can see that's what we've got here. And this is really not too bad. Basically, what we've got going here is, remember in the last section, in section 5.1, we divided monomials. And so what we're going to do is we're just going to break this up into a series of monomials and just do each one of those separately. So basically, whenever you have a polynomial divided by a monomial, you can just rewrite it 5a squared b over 5ab. So you take this part here, divided by that, but then you also have the minus 15 ab to the third over 5ab. And then you also have this part, plus 10 a to the third b to the fourth over 5ab. So because this whole thing is divided by 5ab, we can take each part and divide it by 5ab separately. Okay? So then all we have to do is follow the rules that we did in the last section and divide these out. And so what do I have? I have 5 divided by 5 is 1. And so in a sense these cancel. I've got a squared over a. Well, remember how we did that before? We can subtract the exponents. So really I'm just going to do 2 minus 1 is a to the first, or a, and again that's going to be on the top of the fraction. In this case it's not, yeah, I guess it will matter. It'll be on the top of the fraction because there's 2 a's up here and 1 a down here. And then b over b, these basically just cancel as well. So all I've got left out of all of that is just a. Then let's do the second part. Now we've got the minus. I got a negative 15 divided by 5, so that's 15 divided by 5 is 3. And again, that's on the top of the fraction. A divided by a, those cancel. And then I've got b third over b, so this is like 3 minus 1, which is b squared, and that will also be on the top. So we've got minus 3b squared on that one. Then, last one, I've got 10 divided by 5, which is 2, on the top of the fraction. I've got a to the third over a, so 3 minus 1 is a squared, which is on the top. And then b to the fourth over b, 4 minus 1 is 3. And so in this case, we ended up not having anything on the bottom of any of these fractions, and so I just end up with a minus 3b squared plus 2a squared b to the third. And that would be my final answer. If for any reason each one of these terms were like terms where they had the same variable or variables and the same exponents, then you would go ahead and combine those like terms. But in this case, none of those are like terms, so we're going to stick with that as our answer. By the way, I'm a little out of practice writing with this. I don't know if you can tell. I'm a little sloppy here, so forgive me as I relearn how to write. All right, good. So that's dividing a polynomial by a monomial. Let's move on to the next thing. Now we're going to divide polynomials. This is where we're actually going to get into the long division. Okay. Now this works kind of the same way as if you remember when you were in grade school and you learned how to divide and you set it up. Well, this is going to kind of work the same way. All right, so here's what we're gonna do. This is one way you might see this written. You've got a polynomial divided by another polynomial, and usually this would be something bigger divided by a binomial. Usually is how that'll work. So what we're going to do is we're going to take this x minus 5. This is going to go outside here. Remember how we did this in grade school? And then the x squared plus 3x minus 40 will go in here. Okay, and so we're going to kind of follow that same procedure that we did before, but we do have this x minus 5 out here, so it makes it a little bit trickier, but basically here's what we're going to do. I'm going to say, okay, if I want to see this x, I want it to go into x squared, so I said, well, what do I have to do? X times what will give me x squared? Well, x times x will give me x squared, right? And so that means I'm going to write that up here. I'm going to keep it in the x column here. So that means I go x times x is x squared. So these can cancel out. However, it's not just an x. I also have this 5 out here, right? So I also have to do negative 5 times x, which is minus 5x to complete that. And now what we were doing is, remember, we're trying to get these x squareds to cross out. How do I get them to cross out? If I have x squared and x squared, I have to subtract them. That means I have to subtract that whole thing. I like to put the parentheses and this minus sign out front so I don't forget. This is really easy. X squared minus x squared, we know that cancels, which is what we want it to do. Here's the tricky part. The trickiest part of the whole thing, I think, is this part. Since you're minusing a negative here, that's really what? Adding, right? So what we've really got here is we really have a 3x minus a negative or plus 5x. So what's left is 8x. That's one of the trickiest parts, is remembering this to subtract the second one. Well, now I say, okay, x times what would give me 8x? Well, 8. So I go, oh, this has got to be 8 times x is 8x. But wait, I've also got this 5 here, so I'm going to go 8 times negative 5 is negative 40. Remember, you've got to subtract this whole thing. And if it helps you, you could leave this negative 40 up here, but if it helps you to kind of bring it down here to be with this, that might make it easier. And so now 8x minus 8x, those cancel. Negative 40 minus a negative or plus 40 gives me 0. That means there's no remainder. We'll do one in a second here where we've got a remainder, and I'll show you what to do with that. So with no remainder, this worked out perfectly, so that means my answer here is just what I get up here, x plus 8. Or in other words, since it works out perfectly here, x plus 8 times x minus 5 would give me that polynomial, that trinomial there. Okay, so that's kind of a nice straightforward one, not too bad, but hopefully you're kind of starting to see the pattern that we're going through. And again, remember that minus, minusing that whole thing there, that's the trickiest part, distributing that negative. All right, next one. Ooh, okay, look at this. Here's another way that you might be given a problem like this where you're dividing polynomials. It really is the same exact thing we did before, except for writing it out with the division sign, they put it in a fraction form. So all this means is this a plus 1 is going to be the term that goes out here, and what goes inside the box is the stuff on the top. So 2a squared minus 4a minus 8. Okay, so that's how we're going to set that one up when it looks like that. Let's go through the same steps now. So I've got a times what will give me 2a squared? Well, it's going to go times 2a, right? 2a times a is 2a squared. I also have to do 2a times 1, and so that's 2a. Remember, we have to take this whole thing here and subtract it. 2a squared minus 2a squared cancels, and then negative 4a minus 2a is negative 6a. Okay, be really careful on those. I can't stress that enough. All right, a times what is negative 6a? Negative 6 or minus 6, so negative 6 times a, negative 6a, and negative 6 times 1 is negative 6. Again, we have to subtract this whole thing, and if it makes you feel a little more comfortable, that minus 8 up there, you can bring it down here. Just bring that down. And negative 6 minus a negative, those cancel. And then negative 8 minus a negative, that really is plus. So that means we're left with negative 2. Our remainder is negative 2. All right, so here's our remainder. Oops, that's our remainder. So what do we do with that? Here's how we write it out. When we have a remainder, we're just going to write this out as 2a minus 6, and then minus 2 over what we started with here when we're dividing a plus 1. Okay, so this is going to be what our answer would look like there with the remainder. 2a minus 6 minus this fraction of 2 over a plus 1. So, and again, the minus 2 comes from here, and the a plus 1 comes from over there. Okay, a little trickier there. We've got a remainder, and so so you can kind of see what it looks like there with a remainder. All right, I think we've got one more example here. This is a third way that you might see them ask this question, and where you've got where you've got this polynomial multiplied by this binomial to the negative first power. Remember in the last section, anything raised to a negative power, we'd flip it. So basically this is their kind of tricky way of saying, oh well, let's take this y minus 2 and you have to flip it to the bottom of the fraction, which makes it look exactly like what it did in our previous problem. So don't get too thrown off by this negative 1. All that means is instead of having this, it just means you've got this top one divided by y minus 2. Okay, so then this can kind of get crossed out here. So this y minus 2, the negative first power, just means that's being divided on the bottom. That's all that means. All right, we set it up the same way now, okay? So I've got y minus 2. And now, here's the other thing that you've got to watch out for. You notice on this one, you got y to the 5th, y squared. Oh, where's the y to the 4th and the y to the 3rd and the y? It's missing some things. What I would do here when you set this up is fill this all in. I've got y to the 5th, and then I would say plus 0y to the 4th, plus 0y to the 3rd, minus 3y squared, plus 0y, minus, I'm kind of running out of room here, minus 20. Okay. So the things that are missing there, the y to the 4th, the y to the 3rd, and the y, put those in as 0 because you're most of the time going to need that space there to put something in your answer. So go ahead and put a space in there for 0y to the 4th. All right, let's walk through it. All right, so again, y times y to the 4th gives me y to the 5th. Y to the 4th times negative 2 gives me a negative 2y to the 4th. That all has to be subtracted so that these can cancel. And then what I've got left here now is what? 0 minus a negative or plus 2y to the 4th. So you kind of see why we needed that 0y to the 4th there, because we kind of have to keep our column there to do this stuff. All right, next, 2y to the 4th. Y times what? 2y to the 3rd will give me 2y to the 4th. So 2y to the 3rd times y is 2y to the 4th. Here it is. We also have to go 2y to the 3rd times a negative 2, so that's going to give me a negative 4y to the 3rd. Okay? Remember, we have to subtract this, and again, if you feel more comfortable, bring that down, 0y to the 3rd. So what do I've got here? These cancel. 0 minus a negative makes this a positive 4y to the 3rd. I hope I'm not going to run out of room here. Okay, so 4y to the third. Y times what? Y times 4y squared. 4y squared times y gives me 4y to the third. And 4y squared times negative 2 is going to be a negative 8y squared. Again, if you want to bring this one down, that's going to give you the minus 3y squared. So now I've got these cancel. Negative 3y squared minus a negative, that's going to be plus 8. So this is going to be 5y squared. Again, if you want to bring down the 0y, and you're going to say y times what? 4y. 4y times y is, oops, why did I do that? 5y, sorry. So 5y times y is 5y squared. And 5y times 2 is a negative 10y. So when you subtract all this, these cancel, and you have 0 minus a negative, so that's plus 10y. We might just barely make it here. And then we can bring this negative 20 down, and we say y times what would give me 10y? Well, that's going to be positive 10 there. So 10 times y is 10y, and 10 times the negative 2 is negative 20. And remember, we got to subtract that whole thing, so 10y minus 10y cancels. Negative 20 minus a negative, that's plus 20. Those cancel and give me a remainder of 0. Woo! Yay! So what I end up with here is all this stuff up here. It's kind of got a little confused because I wrote this y minus 2. That's really not part of our answer there. So all this stuff here, your final answer would be y to the fourth plus 2y to the third plus 4y squared plus 5y plus 10. That would be our answer there. No remainder, so we don't have to worry about the remainder there. All right, well, there's a few examples. You got to see a few different ways that the problem could look, what it could look like. You know, one of the ways is with this negative 1 exponent. One was where it's got like a fraction, and one where it has the division sign. But this is the pattern that you follow, kind of like what we learned, you know, just with regular numbers in grade school, to work that all out. So there you go. That's long division, the first part of section 5.2. Next time, stay tuned. In part B of section 5.2, we're going to learn about synthetic division. So there's a different way to do all this stuff, and it might seem a little confusing at first, but in the end, I think you're going to like it a lot more than this. So anyway, until next time, this is Mr. Anderson signing off, and we'll see you later. Bye.